In aeronautics, chord refers to the imaginary straight line joining the leading and trailing edges of an aerofoil. The chord length is the distance between the trailing edge and the point on the leading edge where the chord intersects the leading edge. The point on the leading edge that is used to define the chord can be defined as either the surface point of minimum radius, or the surface point that will yield maximum chord length. The wing, horizontal stabilizer, vertical stabilizer and propeller of an aircraft are all based on aerofoil sections, and the term chord or chord length is also used to describe their width. The chord of a wing, stabilizer and propeller is determined by measuring the distance between leading and trailing edges in the direction of the airflow. If a wing has a rectangular planform, rather than tapered or swept, then the chord is simply the width of the wing measured in the direction of airflow. The term chord is also applied to the width of wing flaps, ailerons and rudder on an aircraft. The term is also applied to aerofoils in gas turbine engines such as turbojet, turboprop, or turbofan engines for aircraft propulsion. Most wings are not rectangular, so they have a different chord at different positions along their span, to give a characteristic figure that can be compared among various wing shapes. The mean aerodynamic chord, or Mach, is used. The Mach is somewhat more complex to calculate, because most wings vary in chord over the span, growing narrower towards the outer tips. This means that more lift is generated on the wider inner portions, and the Mach moves the point to measure the chord to take this into account. Standard mean chord. Standard mean chord, SMC, is defined as wing area divided by wing span. SMC equals SB. Display style mbox SMC equals frac SB. Closing curly bracket, where S is the wing area and B is the span of the wing. Thus, the SMC is the chord of a rectangular wing with the same area and span as those of the given wing. This is a purely geometric figure and is rarely used in aerodynamics. Mean aerodynamic chord. Mean aerodynamic chord, Mach, is defined as Mach equals 2s. Display style mbox Mach equals frac 2s 0 b 2 c 2 d y. Display style int underscore 0 caret frac b 2 c caret 2 dy. Closing curly bracket, where y is the coordinate along the wingspan and c is the chord at the coordinate y. Other terms are as for SMC. The Mach is a two-dimensional representation of the whole wing. The pressure distribution over the entire wing can be reduced to a single lift force on an A moment around the aerodynamic center of the Mach. Therefore, not only the length but also the position of Mach is often important. In particular, the position of center of mass (com) of an aircraft is usually measured relative to the Mach as the percentage of the distance from the leading edge of Mach to com with respect to Mach itself. Note that the figure to the right implies that the Mach occurs at a point where leading or trailing edge sweep changes. In general, this is not the case. Any shape other than a simple trapezoid requires evaluation of the above integral. The ratio of the length, or span, of a rectangular planform wing to its chord is known as the aspect ratio, an important indicator of the lift-induced drag the wing will create. For wings with planforms that are not rectangular, the aspect ratio is calculated as the square of the span divided by the wing planform area. Wings with higher aspect ratios will have less induced drag than wings with lower aspect ratios. Induced drag is most significant at low airspeeds. This is why gliders have long slender wings. Tapered wing. Knowing the area, SW, taper ratio, lambda, display style lambda, and the span b of the wing. The chord at any position on the span can be calculated by the formula Cy equals 2 s w 1 plus lambda b 1 minus 1 minus lambda b pipe y pipe. Display style Cy equals frac 2 s underscore w 1 plus lambda b left 1 frac 1 lambda b y right. Closing curly bracket, where lambda equals c t I p c r o o t. Display style lambda equals frac c underscore room tip c underscore room root. Note: this formula only works if y equals 0 O is the port wingtip and y equals b is the starboard wingtip. Typically, y equals 0 represents the mid-span location. Aerodynamics for students. Wayback Machine. 1. Finding the mean aerodynamic chord. Mach. Image-based mean aerodynamic chord. Mach. Calculator.